analysis, but I want to look at a loop that involves a voltage source that's easy, and a loop that involves a current source which is harder, and we'll show how we get out of the same trouble. So for loop analysis, I'll begin by identifying the different loops. And 1, 2, 3, 4 different loops. Isaac Vaughn, question or? Okay. One confusion with loop analysis has been that once you've identified your loops, you still haven't necessarily clearly identified what you mean by the different loop currents. So I've got my 4 loops here, but what if I call this loop 1, 2, 3, and 4, I can clarify precisely what I mean by the current I1 by labeling it on the picture. I1, I2, I3, and I4. I've labeled the currents around the edge of the loop to show that that loop current is the current as if all the other loop currents were 0. So in other words, I4 in this section of the wire is completely by itself. The current through here is a combination of excuse me, I meant to do I3 and I4. So here the current I3 is by itself. Through that point right there, that current is a combination of I3 and I4. So right here, that's not just I3 by itself, that's a combination of 2 loop currents, and therefore that would be a bad place to label I3. It's not that you couldn't make the problem work if you labeled that as I3, just that your loop currents would be tangled together, and I think it's going to be a lot easier if you label the I3 around the edge. Right, did you have a question? Okay, this loop will give us some trouble because it has a 10-volt voltage source. That's not bad, but it also has a current source. So let's write the voltages around loop 3. So we'll go to loop 3, and I'll start. I tend to start in the lower left, but you obviously don't have to do that. I tend to start in the lower left and go clockwise. So if I start here, I'm going to write that the sum of the voltages around that loop add up to 0. The voltage across a current source, we don't know. And this is, it was when a lot of you were asking me homework questions. Oh, I've got this mostly done. I got stuck on the loop analysis. On the loop analysis, if you got stuck, it was likely you were getting stuck when you saw a current source. The voltage dropped across a current source is not 5. This is 5 amps. It tells us nothing about the voltage drop across it. The way out of this is to invent a voltage, just like earlier we invented the current Ix. Now I'm going to invent the voltage. The voltage dropped across that current source, let's call that V3. I picked V3 because it's around loop 3. And I labeled a plus and a minus side for V3. I encourage you to do the same thing. Some of you might want to just call that voltage V3 without putting a minus and a plus, but then you're not sure which way is more positive, which way is more negative. It's safer to just always label with a plus and a minus. So if I start here and go around the loop, I'd go, would I be subtracting V3 to go from here to A, or adding V3?
Adding.
Adding, correct. Because I went from minus to plus, so that would be up V3. And then the rest of the loop analysis I'm going to go fairly quick through because I think a lot of you are more comfortable with the other details of it. So that would be minus 2 ohms times the current through it. The current through it would be I3 minus I1. That was that 2 ohm resistor. Now I'll do the voltage dropped across that 2 ohm resistor, which would be minus 2 ohms times I3 minus I4. now finally I have to go from here down to there. Should I subtract 10 or add 10? Subtract, yep, because I'm going plus to minus. And that's my equation for loop 3. In the process, I introduced an extra unknown, V3. When I introduce an extra unknown, I have to write an equation that captures that unknown. Here, the equation would be that the current I3, which is this current right here, equals what? How do I?
5.
Yeah.
5 amps.
So I have a current source. So the extra equation is going to be information about that current source. So what this current source is telling me is that I3 equals 5 amps. This current source here, although we haven't used it yet, what's going to be the extra equation for that current source? Well, if this is I2 and that's I4, it's going to be 3 amps plus I4 equals I2. Or in other words, this current I2 splits up into 3 amps and I4. So that when I get to this current source, which I haven't gotten to yet, but when I do get there, the extra equation that I'm going to get is that I2 splits up into 3 plus I4. This one was so simple you almost might overlook it. This is just saying the current I3 is equal to 5 amps. This one, not quite as simple, because this current source is not directly I2 or directly I4. This is a combination of those two. So I2 equals up 3 amps plus the I4.
So even though the extra variable we made voltage is still as I3 equals 5 amps. I think that's just what bugs me.
Yes, but it did bug you with the nodal analysis. With nodal analysis, our extra variable was Ix.
Yeah, true.
But the extra equation was that B minus D equaled 5 volts.
Yep.
It's the same thing.
Same thing,
Okay.
but-
Yeah.
Yeah.
This current plus that current equals I2. Do you agree? The I2 splits up into 2 pieces. So those two combined have to equal I2. Right.
Is it because the current entering the node is equal to the current exiting the node?
Yes.
So-
Yes. If you would rather, it's basically a quick statement about that node. I could have said these 3 currents all going into that node added up to 0. If you feel a little more comfortable with that, you could have just done -3 plus I2 minus I4 equals 0. This is mathematically the same thing that I just wrote. So with circuits that have voltage sources and current sources, then you could have trouble with both loop analysis and nodal analysis. The trouble is very similar, as I've tried to show today. The nature of the trouble is that you have to introduce an extra unknown, and with that unknown you have to write an extra equation. So, Fawn, go ahead.
This is more for general loop analysis. We have I3 minus I1 and I3 minus I4. Will it always be that minus the loop next to it? Basically?
Yes.
It's always going to be that.
It will always be that if you write your loop currents
The same, yeah.
the same way.
Okay.
There's nothing to stop you from writing one clockwise and one counterclockwise, but then you have to pay close attention to the direction.
And then it would be positive, right?
Then you might get them both added together